how we might actually see a use for this in the world that we live around pops up sometimes when we deal with triangles, right triangles. And we need to remember this idea is how do we know the sides of a triangle? Well, our friend Pythagoras stole and borrowed this idea of one side plus the other side equals the long side squared. And so if we're able to do that, let's imagine then that I have a wheelchair ramp and I needed to build a ramp to make access accessible. And here are some of my limitations that I have or information that I know. I know that its run is going to be 120 inches. It's the hypotenuse. The actual length of the ramp itself is 122 inches. So the question I asked then is, well, what's my height going to be? What's that particular height? Well, I like drawing pictures. Drew the picture first. We can add an X here because we're not sure what that height is going to be. And you can see why we need to know that, because if we're going to build it, we actually need to know its dimensions. But we don't know what that is. But we know our building code is telling us that we have to have a very particular run or rise over run, basically a very particular slope that we have. So this being the case then is that I can employ what Pythagoras told us about. One side squared plus the other side squared equals the hypotenuse squared. So x squared plus 120 squared equals 122 squared. We're having some larger numbers here. You might need to pull out your black box and let's reduce that down. So x squared, 120 squared, (122 squared) I can subtract this response from both sides, so I have an x squared equals, looks like I have a 484. How do we solve that particular equation for x? Well, we can take the square root of both sides. When I do that, I'm left with x equals plus or minus the square root of 484. And that's the height in inches that I need to build this ramp to meet our particular city codes that we have. What is square root of 484? Because my tape measure doesn't have that. Square root of 484 is 22. So the dimensions of that height are either plus 22 inches or negative 22 inches. But since we're dealing with an application problem, it's up to us to understand that one of those two solutions may not be the appropriate result because we have a negative height. So I have to be left with a positive height. And my positive height is 22 inches. Yep, making track. So that's a way that we can use and the tools that we learned to solve an application problem.